Going to start shortly on our Java session. Still one more minute to see if anybody wants to join.
Hello.
Hello.
Hey, how you doing? My name is Ramez Khan.
Hi, Ramesh. You're here for the Java session, right?
Yeah.
Oh, awesome. Okay. So I wasn't sure if it was coinciding with another session. Awesome. I'll start recording. If you have any questions, you can interrupt me anytime, okay? Today I was going to just show how to set up Java on your computer and also set up IntelliJ, and then upcoming topics will come later. But today, if we have time, we can start working on some of those other things as well. Okay. All right, so let me start. In these community series, what we're gonna cover will be first installing Java and IntelliJ, because you need to have these to be able to follow up with what's going to be covered in these sessions. And then understand the Java programming language structure. Then we're going to learn some basic Java concepts. When I say Java concepts, it's actually basic programming concepts that are true in across all the languages. Pretty much every single language uses the concepts we're going to learn in this series. So today we'll cover this first part, tool setup, and then I think we're going to have enough time to do this class as well, hello world and the class structure. And then later we're going to learn about print statements, comments, variables and types of variables, conditional statements, comparison of operators, loops, and user-defined methods. Especially these two and these three actually are used in any programming language that you may learn, you may need in the future. So what you learn is transferable to any other language. All right, so here's what we're going to do. First, we're going to go to this website, which is Oracle's website. That's where you get the Java. So when you land on this page, so I'm going to copy paste this one in the chat so you can have it. Let me see in the chat. All right. Okay, so what we're going to do will be downloading it first. So I'm using a Mac, and I have the M2 processor. I think this should be fine with the M2. All right, so I downloaded it before. I'll just double click. Oh, open on the other screen. We'll just continue basic flow of any installation that you've seen before. Right. Okay, so after this is installed, what we're going to do will be, we'll open the terminal. For Windows, you will need to go to the Windows tab in that link and pick whichever one is. Usually the installer is the best one, or the MSI installer. That compressed archive may not work easy. So I'm going to go to terminal, my terminal here, and in the terminal, what we're going to do. So in your case, if you're using Windows, it could be PowerShell. So to open PowerShell, you need to click the Windows and R keys, letter key, and then start the run window, and then just type in CMD, which is a command line, and then it will open the PowerShell. For Mac, it is similar, just here, terminal, and then once you open the terminal, it brings up the terminal. So here, only thing we're going to do will be just checking the version. So I have the Java version 21, which I just installed, and it's set up here. Do you want to install it now, Ramis, or do you already have it, or you want to follow along, or just want to watch? Yeah.
I already have JDK installed. It's
Awesome.
actually version is 15.
15. Yeah, after
That's
8,
fine.
they are pretty much the same. So you're
Okay.
good. Yep. Awesome. Okay, so next thing we're going to do will be installing the IntelliJ. So go to this link, and then here we have the Ultimate Edition, but then we have the Community Edition right here. So Community Edition is free, and then this Ultimate is for companies who pay, but this is good enough for us. So I downloaded it. It's still downloading. All right, so here.
Also, I do have the IntelliJ installed
awesome.
already. So.
Oh, that's great. Okay, so then I'll quickly finish these up for other people who would be watching this later. All right, so now it should be in here. All right. So I had this project before. I will delete this actually, remove projects. Okay. So that's it. So here, this next thing was to connect JDK with IntelliJ. I had 17 here, but now I just installed 21. It really doesn't matter. So what is JDK? So let's quickly talk about that. Is a Java software development kit. So Java is a language, so you can use this language on any text editor. You can create your program. You can write an executable code on any editor. But you need an interpreter for your computer to be able to run this code. So JDK is a tool, the development kit that enables your computer to execute Java code. It also has a debugger, which is really important because we use a debugger to check which part of our code is working or not working. In our case, the testing, we use debugger to stop the code with our test automation code wherever we know the test is failing, or let's say if we're just developing the code for testing, we go step by step with using a debugger, so we know our test automation code runs properly. So you could do backwards, you could do you can use debugger as you're developing, or you can use debugger backwards. After you develop, you can check where it fails. So IntelliJ actually comes with a toolkit of itself. So here, once I click new project, this is what came up. And as you can see here, there's a JDK. So let me try to make this a little bit. No, I could make it bigger. So the language is already picked, Java. I can change it to a different language here. So the location, I already set this location to wherever. I recommend having one location on your computer for all your projects. In my case, I create a separate partition, and that's where I keep my projects. And then here, JDK. So the language is Java, but the development kit is so here now we have the new one. See, this was the previous one I installed. There's a new one. I can pick the 21 as well. So whichever one you pick, you can pick it, and then we can create a project. So here, let's say So IntelliJ did the work for us, and it already has everything set up with the main class here for Java project that we have. Okay. So far, any questions up to this point?
Yes. So when you clicked on the new project, did you select Java? Or there's types of like Java, Maven, Gradle?
Yeah, it was already picked as Java. So if I go back again, let's say if I want to create a new project. So the Java was already selected. And build system, I didn't pick Maven here. It just went to IntelliJ, but you can pick Maven here if you want to use the Maven archetype as a build tool. But we'll learn more about the build tools. So far, I just picked the IntelliJ since this project is just about learning about Java. But Maven we will need, or Gradle, or any other build tool. You may need it in the future when you're using other libraries, other code chunks. So you can import those automatically with using the build control. Okay, so right here, let me just make this one a little bit bigger. Oh, this doesn't work. Okay. All right, so now I think we have enough time to work on this hello world and class structure. So let's talk a little bit about the Java class structure. Java is an object-oriented programming language. So that means it consists of classes, and classes create objects. So we'll learn more about objects. So for now, it may not make sense, but the object has the characteristics of the class or attributes of the class. So whatever class we have, let's say it's a fruit class, and then we have the fruit object. So one is the blueprint, and the object is the actual object. So and then within the classes we have methods, and with using those methods we can work on the object. Unlike some other programming language, Java only has methods which are associated with classes and no functions. For example, JavaScript has functions, and I know Scala has functions. Ruby, I used before, has functions, but Java has only methods. Java classes can be public, private, protected. So we're going to learn a little bit more about these depending on the intended scope. So in this case, if we have a class created in Java, we decide if it's going to be available in other packages, if it's going to be available to all the other parts of the application that we're creating, or if it's going to be private or protected, depending on the scope, the access level. So this determines the access level. They're declared using one of these keywords followed by the class name of the class, curly braces, and so we're going to see these right now. Okay. So here, for example, this is one example of the method. Actually, this is the method. Every Java program must have a method called main method. So this is the runner of Java, any Java project that you will have. Anything that you want to run has to go through the main method. So every Java program must have a main method. So a method is a sequence of tasks for the computer to execute. So whatever code you write in, computer goes through line by line and it executes those. And it executes the codes in chunks of methods. So let's look at the method structure and the class structure here. As you can see here in Java, we have to make it very discrete. We have to make it clear to the computer because we're using a language here, the human language, and computer will interpret this language into its own understanding way. So here, public, we say Java. This is going to be a public class. It's going to be available anywhere, from anywhere in the application. It is a class, and we name this class as Hello World. And then curly brackets sets the boundaries of this class. So you must have curly brackets in Java classes. Within the class, then we have the must-have method, which is the main method. And the main method title, the line, never changes. It is public, has to be accessed from anywhere from the program, anywhere in the program. It is static. We're going to talk about it. So static, it doesn't need an object. Void, it does not return any value. And the name of the method is main. So it's taking string arguments. And that's it. So, and then another curly bracket. So that sets the boundaries. So we set the boundaries of the class with curly brackets, and we set the boundaries of the methods with curly brackets. Any questions so far? Now this is really quick run through, but it will. So now we're gonna actually, I'm going really fast with these. So let's go back to the class here. So here's our main method. And if you want to run this in Java, there are multiple ways of running it. So let me see if I can make this a little larger. Command plus is not that one. I used to use VS Code. It's been a while that I didn't use IntelliJ, so that's why I apologize for not knowing how to make this text larger. Nope. Okay. Right, I think it's still visible. So let's see how we can run this. So as you can see, there are play buttons here. So if you click on this play button, it's going to run the whole code in this class. Run main, everything in this main class. And then if you click on the run next to the method, it's going to run only this single method. So as I mentioned before, the method boundaries are set by these curly brackets. So once you click on it, IntelliJ or any other tool like IntelliJ, like VS Code, they will help you making the code more readable and also helping you out with writing methods. For example, if you want to say like system out, you just say S out and tab. It just helps you with these common methods. Okay. So I'm just thinking if I should go into the details of this loop and everything else. Here, I don't need to go into this because we will learn loops separately. But let's comment. Okay, yeah, let's talk about the comments. So as you can see, there are grayed out fields here explaining what the code is doing. So these are the comments. They may think like, why would we need comments? Because as a programmer, as an SDET, when you're writing code, you may not be, you will write it, you will push it, and then it will be part of a bigger repository. And in that bigger repository, you may not, let's say, look at that code again for like 3-4 months. After 3-4 months, you're going to go back for some reason and then check why you created that chunk of code. And you may not have any clue because it won't be as simple as this. You may use some different methods, different structures, different programming structures, and you may not know why you have it there. So there, having the comment is going to help you understand why you created. So it is a best practice for any chunk of code. As you can see here, as a good example, they put these comments everywhere in this code. This is a little overdoing, but it's a good example. So you want to have a comment before writing any code. And that's also important in doing pseudocode. So let's say, and then this is how you achieve it. If you just do 2 forward slashes, then computer is not going to read that line. So you will know it's not a code to be executed. It's a comment. So that's how the computer knows. So pseudocode. Pseudocode means before you start writing any code, you are thinking how you're thinking like a programmer, how you want to write your code, what the logic is. So so before writing anything, you say, okay, like you can say, for example, I will, let's say here within the main, let's delete all these, right? And here we had extra because this was the loop for loops. Okay, so here's our first comment. We're going to say, I will print hello world with using print statement. Okay, so now I know what I'm going to do. If I just S out, this means system out print line. And here I can put any text, any string. String is a text. World. And the system now. So I showed one way of running it. You can use display. You can run from here, or you can right click and run it. And it just wrote hello world here. Okay. And then print line, let's say I want to do, what else I can say? If I want to, I can write math operations within this too, but it's better that I don't get into those today. Yeah, so that's all about the print statement. Any questions about the class structure and so far how we're running this code? Okay, no questions. All right, so I'll move on to my next slide. Okay, so system out print line. So the print statements are important because, so you may think, why would I need to print anything on my code? This gives information to do to you actually to log something. For example, let's say you're running a test, and then in the test during any point, let's say if the user, let's say, couldn't enter the appropriate value or a proper input, then you want to say an error message. You can say, for example, let's say in any chunk of code, you will say, please enter correct input. So whatever the chunk of code you have, at some point you want the user to know that the input they entered is not correct, so they need to enter correct input. So that's when you need to print something. So then, when the code runs, let's say it came to this point, and the input, there's an if statement, there's a conditional, and then based on that conditional, the system knows the input entered there is not valid. So you want to print this out. So that's why you want these print statements to inform the user or inform yourself when you're running it. So when something goes wrong, you want to know what's wrong. So imagine you have hundreds of lines of code, and at some point, in that you're running the hundreds of lines or maybe thousands of lines, and you don't know exactly what's wrong. And when you have these print lines, print statements, then it tells you where the problem is. So the comments, we talked about it. It's like a pseudocode, preparing your pseudocode, or it's just to inform future yourself or anybody who reads your code what the intent of the code is. So Java, the comments in Java or any other programming language is extremely important. There was something that I created, I don't know, maybe like 13, 14 months ago, and I couldn't tell why I created that type of loop or whatever that. I think I used collections at that level. So I couldn't tell why I created, because I did not put a comment on top of my code chunk when I was creating it. So I need to figure it out, or I would delete it. And what happens is sometimes there are things done in a certain way for a reason, and then when your new you looks at that code chunk and doesn't make sense, you may delete it, and then it may cause a failure in your test suite. So that's why it's always good to write a comment on any chunk of code to explain what the intent of that code is. So there are two types of comments. We mentioned the first one is being with the double forward slashes, and there is a block comment. So this is more exploratory. So if you need more than one line, instead of going with the two forward slashes on every line, you can use a forward slash and star, and then you can close it with star and forward slash. So we start with forward slash, star, star, forward slash, and you can write any code, I mean any comment in between these. For example, here there's a method. It's a public method. It's void add numbers, int a, int b. So we'll talk about the variables, and it returns a plus b. So it says this method takes two whole numbers and then returns their sum. There's a problem here. It's not a void. It should be int actually. Okay, so I will stop here because I want to take more time on variables and types. Again, like I said, most of the concepts that we're going to learn in Java are applicable, transferable to many other languages that you will use, you may use. So the good thing is once you understand the core structure of any programming language, then you won't have any problem learning any other language. So that's why it's really important to understand what is used for what. So here again, just to go back, any object-oriented method, object-oriented programming language will have a class, because classes define the objects. And then in those classes, you're going to have methods, definitely methods. But Java doesn't have functions. Some will have functions. They are very similar, but they all have the same structure. Even you use Ruby, C++, or JavaScript, all of them will have this similar structure. So once you understand this takes arguments, it takes, we're going to talk about parameters, arguments, whatever it takes. So it processes those and then it spits out something. So here, for example, this method named here, it takes two parameters, it takes two inputs, and then returns a value. So, and this structure is same across all the programming languages, and everything else we're going to learn from this point on in Java are applicable for any other language that you're going to learn. Okay, I'll stop here today. And if you have any questions, again, wherever this is posted, you can add comments and ask your questions. See you next time.